Hi, I am Sanghi Ra, and today's lesson is on circular motion. Within it, there is angular motion, angular velocity, angular acceleration, torque, angular momentum, and the conservation of angular momentum. What is angular motion? It is an important part of the way objects move in the world, and linear motion plays a part in it. It uses units of distance, in this case, meters. These linear distances are measured in meters with displacements from an arbitrary 0 point. One way to visualize angular motion is through imagining yourself facing north. Let's say this direction is 0 degrees. But by rotating your body east, it has become angular motion. You have rotated an angle of 90 degrees. Now let's face south. That is another 90-degree rotation from east, but it is a rotation of 180 degrees from the original point north. When we rotate another 90 degrees to the west to face west, it is 270 degrees from north. By rotating another 90 degrees back to the original point north, a full rotation of 360 degrees happened. When measuring angular motions, you either use degrees, radians, or revolutions. To figure out the radians, you multiply the degrees by pi divided by 180. While figuring out degrees, you multiply the radians by 180 degrees divided by pi, and 2 pi is 1 full revolution. Pi divided by 2 is a quarter revolution, or 90 degrees, and pi is a half revolution or 180 degrees. Now, what is angular velocity? A good example of it is found within our car's gauge called tachometer. This measures the number of revolutions per minute of the engine's crankshaft. If the car was not to be moving at all, it will show that it is 500 to 1,000 revolutions per minute, or the idle speed. If it is not moving, why is there still any speed though? The speed of which it is referring to is the angular speed, which is the number of revolutions per minute. If you were to excel, the crankshaft would rotate at a higher angular velocity even if the car is not moving. Simply put, it is a measure of the rate of change in angular position. In 10 seconds, you can make 1 full revolution. This would mean that your angular speed is 360 degrees per 10 seconds, or 36 degrees per second. Other ways of saying this would be 0.1 revolutions per second, or 0.2 pi radians per second. What is angular acceleration? Well, if there was a stationary merry-go-round, it wouldn't be rotating. So the angular velocity is 0. However, if you start pushing on it so that it turns at a velocity of 1 revolution every 4 seconds, it has accelerated to this non-zero angular velocity. If the angular moves at a constant angular velocity, there would be no angular acceleration. Since accelerations are changes in velocity, it uses the units of radians per second, but they are dimensionless, so it uses 1 per second squared. What are their symbols? Angular positions are represented by thetas. Angular velocity is represented by omega, and an angular acceleration by alpha. What are torques? Torques are parallel or the linear concept of force. It is simply the application of a force at some distance from a pivot point. You can use the formula torque equals force times radius, or T equals Fr. All objects have a property known as their moment of inertia. It is a measure of how the mass is distributed and affects how easy or how hard it is to start an object from rotating or stop rotating. Rotational motion refers to its moment of inertia rather than the object's mass. All net torques produce an angular acceleration. What is an angular momentum? Rotating objects have an angular momentum similar to the way moving objects have linear momentums. P equals mv is angular momentum. It is equal to the product of the moment of inertia and angular velocity. You can use L equals I omega. In terms of mass, velocity, and radius, it is L equals mvr. But what is the conservation of angular momentum? Both linear momentum and angular momentum is conserved. So, in a closed system, angular momentum is neither created nor destroyed. Angular momentum is in one state is equal to the angular motion in another state, and that value is constant. An example of a spinning ice skater shows that the spin starts at a given velocity with her arms stretched out, but when she pulls her arms in, it redistributes the mass within a smaller radius. While her mass is constant, the radius is decreasing, so she spins faster. An example of circular motion is a yo-yo trick called around the world. The yo-yo spins free, but the string keeps the yo-yo moving in its circular path. Without it, the yo-yo wouldn't come back up, and it would rather move off in a straight line. The tension between the string and the yo-yo keeps it in circular motion.